A clean AOSP build can hold your machine hostage for half a day. So how do you reclaim your productivity? Here is what actually happens under the hood. The build system is a complex beast, but it has levers you can pull to dramatically speed things up. As you can see from the highlighted text, the time difference between a laptop and a workstation is staggering. But the trick that took me 3 years to learn is that the right commands can close that gap significantly. Now let's look at the first and most obvious lever, your CPU cores. How does the build system know how hard to push your machine without freezing it solid? By default, the build tool Ninja is quite clever. It queries your operating system to find out exactly how many CPU cores and threads are available. Notice the highlighted line here? It's saying Ninja automatically spawns a swarm of parallel tasks, one for each thread, trying to max out your processor. A 16-core CPU will get 16 jobs running at once. But what happens when maximum is actually too much? What if you need to build the OS but also need to answer an email without waiting 30 seconds for a new browser tab? You can tell Ninja to back off. The highlighted text shows the -J flag, which stands for jobs. This lets you manually set the number of parallel compilation tasks. This is your master control valve for CPU usage during a build. Most people just run M and let it fly, but explicitly setting a job count is a pro move. For example, on my 32-core workstation, I never use all 32 for the build. So when would you actually do this? Look at the highlighted example. If you have a 32-core machine, running M-J24 is a common courtesy to yourself. This command tells the build system to use only 24 of your cores, leaving a full 8 cores free. This means your desktop environment, your web browser, and your IDE remain snappy and responsive, while the massive AOSP compilation churns away in the background. It's the key to multitasking during a long build. Now let's see what that looks like in the terminal. Here is the command in its simplest form. The text you see highlighted, M-J4, instructs the build system to run a maximum of 4 compilation jobs at any given time, regardless of how many cores you actually have. This would be a very slow build on a modern machine, but it's perfect for a low-power laptop or if you're running multiple heavy tasks. But managing CPU is only a small part of the optimization story. The real magic comes from managing your disk. If you could only make one change to your build setup, what should it be? The answer is on your screen right now, ccache, the compiler cache. Most people trip over this because they think the build system already avoids recompiling unchanged files, which it does. But ccache operates on a much deeper and more powerful level. It's not about skipping files, it's about remembering the result of compiling them. Let me show you how it works. So how does this cache actually save you time? When the compiler turns a C++ source file into machine code, it creates what's called an object file with a .o extension. The highlighted text points to this exact mechanism. ccache intercepts this process. It saves a copy of that compiled .o file in a hidden directory, using a hash of the source code and compiler flags as the key. The next time you build, it checks the hash, finds the cached object, and provides it instantly instead of running the compiler again. But the real payoff comes after you wipe your build. Here's where it feels like a superpower. Sometimes you have to run make clean, which deletes your entire out directory. Without ccache, you're starting a multi-hour build from zero. But with ccache, as this line highlights, that 3-hour C++ recompilation becomes a 20-minute process of simply copying cached files back into place. It's the single biggest time saver in AOSP development, period. So, let's get it set up. How do you tell the build system to actually use ccache? It's just 2 environment variables you set in your shell profile. Look at the highlighted code block. The first line, export use_ccache equal to 1, is the master switch that tells the AOSP build scripts to enable the feature. The second line, ccache_exec, points to the ccache binary itself. Once these are set, every build you run will automatically try to use the cache. But first, the cache needs a place to live. A cache is useless if it's too small. So how much space should you give it? The highlighted text recommends 50 to 100 gigabytes, and I strongly agree. AOSP is enormous, and a small cache will constantly be evicting old entries, reducing your hit rate. The command you see here, ccache-m50g, sets the maximum cache size. The trick that took me 3 years to learn is to put your ccache directory on your fastest SSD. The disk I/O speed is critical. Once it's running, you'll want to check if it's working. Is your cache actually being used, or are you just wasting disk space? There's a simple command to find out. As the highlighted line shows, running ccache-s will print a full report of your cache statistics. It shows the total size, number of files, and most importantly, the hit rate, the percentage of times the compiler found a cached object instead of recompiling. A healthy hit rate after a few builds should be well over 90%. Now, ccache is for recovering from clean builds, but your daily workflow should avoid them entirely. The fastest build is the one that does the least work. So how do you avoid a full build in the first place? Here is what actually happens under the hood. You should almost never, as the highlighted text says, perform a full clean build. The Ninja build system is designed for this. When you just type M, it doesn't blindly recompile everything. It first scans the entire source tree, checking the modification timestamps of every single file against the output files. This is called an incremental build. Let's see a concrete example. Imagine you've changed one Java file deep inside Activity Manager service. What happens when you type M? The build system quickly sees that only that one file is new. As the highlighted text explains, it will then recompile only that specific module, in this case framework.jar, and any other modules that directly depend on it. It intelligently skips the other 99% of the OS. This check takes seconds, and the build can finish in under a minute. But we can go even faster. What if you don't even care about dependencies and just want to build one single app? If you're iterating on the settings app UI, you don't need the build system to even check if the Bluetooth stack has changed. The highlighted text shows the solution. You can tell the build system the specific module you want to build. This is the key to rapid, iterative development on a single component, like an application or a library. It's the most focused build you can possibly do. So how do you invoke this module-specific build? It's incredibly simple. Instead of just typing M, you type M followed by the module name, like M settings. As the highlighted line explains, this command completely bypasses the check of the entire OS tree. It finds the android.bp file for settings and immediately starts compiling it. A full incremental build might take a minute. This can take 5 seconds. This completely changes your edit, compile, test loop. Let's see the full workflow. Here is the complete rapid development cycle in 2 lines. The highlighted code block shows you everything. First, you run M settings to compile just that one APK. Second, you use adb install with the -r flag to reinstall it on your connected device. The path out/target/product/generic/system/app/settings/settings.apk shows you exactly where the build system places the output. This 2-command sequence is the fastest possible way to get your code changes from your editor onto a real device for testing.
Enjoyed the video? Hit like and subscribe for your regular dose of AOSP customization. Thanks for watching. See you in the next one.